Okay, we're in 1-6 for Algebra 2, and the title of the lesson is Linear Systems. I'm just want to show you two things in here. 1-6, Linear Systems. One of them is if I give you 3 inequalities, for example, x is greater than 2, 2x plus 3 is less than, or maybe let's put this in a different way, it'd be a little easier. If I said 2x is greater than 5 and 2x plus 3 a negative, let's change that to 3x plus 3 is less than 0. So let's see how these look. Except all 3 of them usually are going to be the same symbol. I'm going to do all of them being less than. Sorry about that. Let me change that over here. So if we do less than, and less than, then hopefully usually x less than 2 would be like, if you're up there above 2, we're on the left side of it. If you have, sometimes they'll also add in a couple of restrictions like y has to be greater than 0 as well. So y greater than 0 would mean we're up here. You might also say x is greater than 0, so it's over there. And then the last one, let's see, if I go up 3 with a slope of 3, see that less than is going to be below it. You could check that with testing a point. And then the 2x plus, if you subtract that 5 over here, you'd have 2x minus 5 is less than 0. So a negative 5. And then 2, a slope of 2 would be coming up here somewhere. But anyway, this region right in here where everything overlaps, that's called the feasible region. But so I just made that up. Some of that might not, that last equation didn't look like it fit in there very well. Then sometimes that's referred to as linear programming, and sometimes there's another thing you need to do, and that is check all 4 corner points, or 5, however many corners there are in the region. That's the feasible region. And then they'll give you one other equation where you check you either want the largest value or the smallest value that you can get from any of those corner points. So maybe it was 2x plus 3y, and we wanted the maximum. If I'm going to guess it's probably this one, but that's kind of how that linear system or linear programming works. The last one I want to go through with you is, so hopefully you remember that this is the general form for a quadratic. If I give you 3 points for a line, so if I gave you these 3 points and told you that they fall on a quadratic, and I want you to find the equation of the quadratic. So 1, 0, negative 1, 11, and 2, 1. If those are the 3 points, well, here's how this works. The first number is the x, right? And the second number is the y. So if you take this first point, the x being 1, 1 squared times a, is that just a? And the next one, b times 1, because x is 1, so that's b. And the third one is c, and we just have c, and then equals y, and the y value that corresponded to all those was 0. And the next one is put in a negative 1 for the x's, so that would still be a color code these again. So negative 1 squared is 1 times a. Negative 1 times b is a negative b. And then this c is still just c. And the y that went with all that was 11. The next one, 2 for the x, so 2 squared would be 4a. 2 times the b, the c, and the y that went with that 2 was a 1. All right, now then this next part is probably where it's going to seem like magic to you, but it uses the matrices. Hopefully you've done a little bit. If you haven't, that's okay. We're going to use these 3 equations, and you pull off the coefficients of all these. So in the first row, I have 1, 1, and 1. The second row, I have 1, -1, and 1. In the third row, I have 4, 2, and 1. If you took those all times the ABC matrix, that would give you the left side of all the equations equals to the right side of the equation, 0, 11, 1. So what we're really trying to solve for here are these A, B, and C that are right in here. We want that alone. So what we have to do is get rid of this first matrix. So if we can go into www.desmos.com/matrix, hopefully you can figure out how to use that program, because what you're going to do is we got to get rid of, we're going to call this matrix A, this matrix X, and this matrix B. We want matrix X all alone. So what we need to do is we got to get rid of this matrix A by doing the inverse to it. Inverse of something makes it go away, but you have to do it to both sides. Matrices, it's important if it's on the left on one side, you do it on the left on the other side. So what we're going to do to solve this, that got rid of this, solving for ABC. In matrix A, in Desmos, you're going to make it a 3 by 3 with that 1, 1, 1, the 1, -1, 1, the 4, 2, 1, and then in matrix B, you're going to put the 0, 11, 1, and then down on the new screen, you're going to go matrix A to the -1 power. That means the inverse. It's what we did to undo it here to get our answer. So I'm going to, you need to go matrix A inverse times B equals, and Desmos will tell us the solution for the A, B, and C, because that's what we were finding. You know, the A inverse B was the A, B, and C, which were the coefficients that we needed for our original problem. Whew, that's a good one. Hope you followed all that. Hope we'll go through it in class, but maybe you can watch this again. All you have left to do is actually make sure you figure out how to use the Desmos matrix calculator.